Right, types of reactions, the basics. So throughout the beginning part of this chapter, you've been learning how to write chemical equations, also known as chemical reactions. Okay, we've had reactants and we've had products. So for example, a reaction might look like this. A reaction might look like this. A reaction might look like this. Whoops. Okay. These are not balanced. Okay, so don't worry about that. But do all of these reactions look the same other than the types of elements that are in them? Do they all have the same number of plus signs? Do they all have the same number of elements and compounds? No, they're all different. Notice on this one, we're combining two things and producing one product. On this one, we start with two reactants. We end with two reactants, but things got all mixed up. On this one, we only started with one reactant and we ended with two products. Okay, so these are all different types of reactions. Different things form and different things happen. We have names for the different types of reactions, and we're going to learn what makes a reaction what it is. So first, let's list the names of the types of reactions, and I'm going to explain a little bit about what they are. So the first one is called synthesis reactions. Then we have decomposition, single displacement, also known as single replacement, double displacement, also known as double replacement, and combustion. So now we just need to match these names up with some examples. Okay, you will need to, if you are given a chemical reaction, you have to be able to identify the type by looking at it. So I'll give you some tricks. Here is an example of a synthesis reaction. What do you notice about this reaction in terms of reactants and products? Not looking at necessarily the chemicals involved, but the pattern. Okay, if you think patterns for this, you're going to be better off. What do you notice? It goes from two things to one thing. What does synthesis mean? Synthesizing. If you've ever played a synthesizer, it combines sounds. Okay. Synthesis means to put together or to combine. So a synthesis reaction has the general format of two reactants. So one reactant plus another reactant is going to give you a single product. In a synthesis reaction, you will always have two or more reactants, meaning there will be a plus sign. So if there is a plus sign on the left side of the reaction and no plus sign on the right side of the reaction, that means that you had a synthesis reaction. So look for your arrow. If there's a plus sign on the left and no plus sign on the right, it's synthesis. Okay. The plus sign just means you have more than one reactant. No plus sign means it is a single product. You could have multiple reactants. You could have A plus B plus C. And they will all come together to form a single product. Okay. Now we know, because of rules of formula writing, that this isn't going to necessarily be ABC. We may have different subscripts in there. Okay, things may look a little bit different, but all of these elements will appear together somehow in the product. All right, so that is synthesis. Decomposition. There's an error here, by the way. Decomposition is the opposite. When something decomposes, like a body, it breaks apart. So in a decomposition reaction, notice we have one thing to start with, so no plus signs, and then it breaks apart into multiple products. So that's a picture of what's happening there. So the general form here is AB produces A plus B. So in other words, a single thing breaks apart into two or more reactants. I'm just going to put it up on the screen again. So a decomposition reaction will always have a single reactant and two or more products separated by plus signs. Again, there could have been 3 elements involved here. We could have multiple plus signs, but there will always only be one thing on the reactant side. And again, I'm not using specific elements here. You should be looking at patterns here. So no plus signs, plus signs. All right, now they get a little bit harder. Okay, so those first 2 are pretty straightforward. They're pretty easy to recognize. The rest of these reactions, again, you're going to be thinking patterns, but we have to think of element versus compound. So let me show you the way we represent elements in our patterns. An element we will represent by a single letter. Okay, even though we know some elements have a 2 after them, we're just going to represent elements by a single letter, like A or B or C. Okay. Our compounds, we're going to show 2 or more letters put together without a plus sign. So an example of a compound, we're going to represent by like AB or BC. Okay, notice there's no plus sign. That means there's 2 or more different elements, which makes it a compound. Okay, so just so you recognize when I put these patterns up here, what these stand for. In a single replacement reaction, here is an example. Notice we have an element and a compound on the reactant side, and an element and a compound on the product side. That is a single replacement reaction. So the general pattern here is, and again, don't really worry about this. We'll explain this when we talk about the formation of these reactions. So maybe just do this first one. An element plus a compound produces an element plus a compound. We will learn later that what's really happening is some of these elements are switching places, okay? But that's the next part of the chapter. So the pattern here again to recognize is when you have a compound and an element on each side. So meaning a compound and an element as your reactants and a compound and an element as your products. It does not matter if the element is written first or the compound. So for example, this could have been okay, it's still an element and a compound. An element and a compound. So it doesn't matter how they're written. Just like in math, 2 plus 1 is the same as 1 plus 2. Okay. Double replacement or double displacement. What do you notice about this reaction in terms of patterns? We were talking about elements and compounds in the last one. So what types of reactants and products are in the double replacement reaction? What double what? Two of what? Yeah, there's two reactants, but they are both compounds. Okay, so in a double replacement reaction, you will have all compounds. Okay, so compound plus compound produces compound plus compound. There will be no individual elements in a double replacement reaction. And again, we'll learn later that what's really happening in this reaction is we have two elements switching places, which is why it's called double replacement. Okay, so the rule for double replacement reactions is that a double replacement reaction will always have two compounds as the reactants and two compounds as the products. Okay, last one. These are the combustion reactions. These look completely different than all of the reactions. These are actually the easiest reactions, but for some reason, students always screw this one up. Combustion reactions were the ones you had a hard time balancing. Okay, combustion implies we are burning something. Okay, combustion means burning. A combustion reaction will always have a hydrocarbon. I'll show you what that means. That is the source of fuel, and you must have oxygen to burn. Okay, so your reactants are going to be a hydrocarbon. A hydrocarbon has carbon and hydrogen in it, and sometimes oxygen. Sugars are hydrocarbons. The numbers here, the subscripts will vary. So some examples of hydrocarbons. CH4 is a hydrocarbon. It has carbon and hydrogen. C2H6 is a hydrocarbon. It has hydrogen and carbon. Okay, so that is one of your reactants. One of your reactants will always be a hydrocarbon. So on the left side of the arrow. You have to have oxygen in order to burn. Without oxygen, you will not have burning. So that is another reactant. I'll leave that up there for a second before I put the next one up. Okay, so you need a hydrocarbon and an oxygen as your reactant. Yes. These will always be the reactants in a combustion reaction. Again, it could vary. This could be C2H6 plus O2. It could be CH4 plus O2. This could also have oxygen in it. Okay, but it is still a hydrocarbon because it has C and H in it, plus O2. Okay, so those are always the reactants in a combustion reaction. The products are always CO2 and water. And those are the only products in a combustion reaction. So notice, other than the hydrocarbon, They are identical. So the only thing that changes in a combustion reaction is the particular hydrocarbon that you use. What makes these challenging is the fact that they are very hard to balance. Okay, so the coefficients will look very different depending on the hydrocarbon that you have. Okay, so the general framework is just the hydrocarbon plus oxygen produces CO2 plus water. So if you see CO2 and water as your products, it's probably a combustion reaction. So just check your reactants. And if both of those are present, then it is combustion. Notice that this does not fit any other of the rules, okay? Because here we have a compound and an element and a compound and a compound. So that didn't match up with any of our other rules either. But these are easy to identify by the product. Okay, so here's another example. All we've done is change the hydrocarbon. Everything else was the same. All right, we're going to stop with that because tomorrow we're going to start with a short sorting activity. For the remainder of the period, if you did not finish your pages 6 and 7, you need to work on those now. Okay, if by the end of the period you have completed more, you may come back and I will give you a few more points. But at this point, it is considered late, so you will not get full credit unless you're absent. I know you can't talk. You won't be able to get So Liam is not contagious, just so you know. He may cough a lot though, because he's had some bronchial spasms. So if he has a coughing fit, you'll know why. He's not contagious with anything. Liam. Not yet. That's what we just learned. We'll be working on that tomorrow. We fly through this pretty quickly.
It's gonna be a class day.
Yes, that will be a class date, but I'm not gonna open it. Okay, 'cause yes. I'm gonna pass out your chapter 11 test review. Okay, we've actually now talked about everything on here, but we are gonna practice more with these reaction things. Again, because, and some of you will pick up the pattern quickly, but if you're not a puzzle person, you may not be too happy with it.